My name is Pius Winterler. I'm 36 years old, married, live in Zurich with my wife. My hometown is Vilsbach, and I work for Ferro as field application engineer, but currently also build up our distribution partners in EMEA for construction progress documentation. And I'm also having a second role as field application engineer. So you see, I wear quite a lot of hats right now, but I appreciate this ability to just develop myself and see where this leads me to. Today I would like to talk about the detailed damage assessment, so where we understand what damage has been done and then utilize our knowledge about that to plan to rebuild parts of Ukraine. My background in that is also that I work since years together with different police stations all over EMEA, also together with the police stations and forensics teams in Ukraine, so who are specialized in documenting damage. It must be done because when you document it, you can also know where to send the bill to later on, and you have a documentation to make this also proven. So it's really waterproof, watertight evidence of what has happened. So our basic concept, which we always have, is we want to collect data on site with different devices. We want to then decide what we want to go forward with it. When we decide to move forward with a project, we start to process this data, and then in the end, we have a detailed plan on how we want to rebuild it. We can visualize what we want to do, and we can also visualize this remotely. So because everything can be done and presented over platforms, this ensures that we do not have to go all the time on site, and we can look over the shoulders of others from afar. First of all, of course, you need to get an understanding what is going on in Ukraine. And we saw today in the morning with the presentation how this affects a lot of areas within Ukraine. And also for the housings, it's good to get just a general overview of which houses are affected. But this is not part of our technology, but it's just important to understand what is going on before moving forward. We go then into more details. There are technologies, not ours, which also allow to assess the damage within cities. So you use drone technology, use AI to then really understand which of the buildings have been affected. You can then break this down into different building types. So what kind of buildings have been affected, and also what kind of damage you see from above. But of course, this is not covering all of the building. This is not covering all of the damage, because to really understand what's going on, we need to go inside the building, and we need to capture this data from inside the building. And here our technology comes in. You see here, this is a real project. This is a real site from Irpin, where a house has been affected by different events which have destroyed part of the building. We see on the left side that the staircase is pretty much intact. Nothing has happened there. But the right side, where is a habitat, where there's a flat, this has been severely impacted by a fire. And the goal is to get this information, to get this data then in front of specialists, that they can start to decide how to move forward. Is this a severe damage which needs to probably have even affected the structure, that we need to exchange the structure, or is the damage just okay, that we can just take down the or repaint it, you know, and just say, okay, this is enough, we wash it down, we repaint it, and then we move forward. So when we look at the building, this is how it looks when we captured it with 3D laser scanning. This is done by our partners, Everscan, who have several offices and workers in Ukraine, and they deploy this already to just document the damage. Everything here is user independent. That means whoever is pushing the start button will come up with the same results, and this is on a millimeter accuracy, and it's also a technology often used within the forensics teams to really see what has happened. So if somebody later challenges you in court and say, no, this has not happened, we haven't been there, that was not us, you just make up any kind of story, this is clear, solid evidence which you cannot manipulate, you cannot fake it, and you can just see, okay, look, this is the real status at this moment in time, this is how it looked. But we are not confined to that. So what we see is we first get all this data and we bring this then into our systems. So we bring in captures and we call this then unstructured data. Unstructured data is just data where you have like a photo, but you don't know what is on the photo. You have a point cloud, but you do not know what it does represent. But it's important to have it because this is the best representation of what it is there right now in that very moment. You need to understand then what kind of level of details you want to achieve in your documentation. So you can go for, let's say, very accessible ones like smartphone photos, 360 images, written reports. You can do this pretty much immediately without a lot of investment, and it gives you already a lot of information about what has happened. When we want to go into a macro planning, where we then generate like plans out of it, BIM models, we then utilize also smartphone and LiDAR scannings or drones to get an overview of what's going on. But the highest level, I would say, is then prefabrication designs. So when you want to go into prefabricated design and not finalize your fabrication on the construction site, but finalize it in different fabrication buildings all over Europe, you just need to have a millimeter accurate documentation of what is going on there. So because you can make this documentation remotely, you can make this documentation on site in Ukraine, it means that when you decide to rebuild this building or to repair the building, that you then can just take this data, plan on it, fabricate according to that data, and then just bring everything which you fabricated on site, and it fits on the very first try. And this is a very proven concept. It is used as a standard by several automotive manufacturers who use this approach on a regular basis to just update their production line. But we can utilize this also now to just rebuild much more buildings faster by having utilized remote documentation, remote planning, and also remote manufacturing. So once it is done, we transform this data into the BIM models, into real-time database to just understand how everything looks like and then go forward with our planning. And last but not least, everything which we documented at the start of our projects can also be used as a starting point for continuous construction documentation. We talked about today a lot about the prevention of corruption. And corruption prevention also means that we must be able to audit what's going on, not only when we start planning, but also during the construction phase, to understand what is going on the construction site, how is the progress moving forward, what materials are around there, and is it as I planned, and is the material which I ordered really there, or is there a cheaper material which I did not order? And this allows you to, again, make a reality capture on site, use the damage assessment as the first start, and then just go forward with your documentation till the end of the project. In the end, you have then data for decades to come that you can make sure that when you rebuild Ukraine, that you rebuild it as you ever have planned and envisioned it. So in that case, I would like to thank you very much, and I will move forward now to the panel and Q&A.
Thank you very much, Pius. You mentioned a few really interesting things. You mentioned, for example, that what you are measuring, your models, will be base for prefabrication. So one question from my side is, can you combine your point clouds and your pictures with augmented reality? Can you send somebody on site in a damaged house with an augmented reality and he knows exactly what to do and where to do?
For the moment, in reality, we are not using augmented reality right now in that form, but we utilize the captures to train the employees up front, so they can go and visit the construction site digitally, they can walk through that site and prepare themselves mentally. And the benefit is that we already know what expects us, and we can walk through the site digitally before we go there. We are coming in much more prepared, and we're also aware of potential dangers and the potential hazards. Yes. So we're not walking into dangerous areas without being aware of it.
Yes, thank you very much. And I mean, if you prefabricate any product and you have to place it on the right place, then you need to this let's say this method of BIM to field instead of field to BIM. But this is really something you take care.
Yes, and I think one of the fastest growing customer base we have now right now for our products are, interestingly, staircase manufacturers and people who work in metal construction. So if you need to bring something into the building, like high-class furniture, staircases which must fit from the first try, but also balconies and railings, then it's just better to have the information right now available and make sure that your fabrication is checked before you go there out. So you can make sure that once you have fabricated it, or before you even fabricated it, that it will fit 100%. And this process quality is just one of the crucial decision factors for applying this technology.
Thank you very much. BIM, for all of you who doesn't know what is BIM, BIM is Building Information Modeling. This is the method to make this change from the physical working to this digital working. So thank you very much, Pius. One last question. In the assessment of a building, of a half-bombed building, half-destroyed building, are there already methods with X-ray? Can I do X-ray with a concrete column to see it's still working or not?
How can I say? Using X-ray is something we often get asked for, but we always advise against it because the amount of energy we would need for X-ray, we would all glow green in the dark the very next night. So we would need much more radiation than it is healthy to utilize. There is some technology which uses electromagnetic waves, which can be deployed, and I believe that's something which we can also use to go forward.
So let's come to our next speaker. It's Iria Bolosa, and yes, welcome on stage here.
Thank you so much, Thomas, and heartily welcome from my side. I'm really inspired to talk today about what we're doing at Quantum Basel. So I would like to make a visit with you to the lovely Arlesheim by Basel to maybe inspire you a little bit about what we're doing there and how we have a look into the future. So I think the best way to do that is starting with a film. And before I start, my name is Iria Bulosa. I was a few weeks ago still the assistant of the construction team, and now I'm the new site manager at Uptown Basel. So thank you. This is Uptown Basel. We have here 75,000 square meters. It's actually the pioneer. I will sit here. And we want to go from the idea 2050 to be a Europe new innovation center for the industry till 2030. As I mentioned before, we're in Arlesheim. That's a few meters to Basel, so 10 minutes probably. And we want to connect with all the world. Let's see. This film, it's actually something it's weird about it, but okay, I will improve. So the thing we want to do in Uptown Basel is we will have over 50 international enterprises from all over the world, put them together and be together innovative, bring new solutions inside for the Industry 4.0. Of course, we want to help Switzerland to not go into the industrialization. A lot of people are talking about it in Switzerland. And with help of new technologies, as maybe quantum technologies can help us to bring the new production into Switzerland and not letting us lose this innovation part. We are working as well, as Thomas mentioned before, with a lot of different kind of companies. One of them is, for example, Straumann. They will come in till 2024. They're doing with 3D printing all the dental you may need, like from the sick bones. And this was actually our investor. I will talk a little bit about him afterwards. He's a private investor. He invests 500 billion into Uptown Basel. And we are doing a lot of events as well. Because of the collaboration part, I will like to introduce you more about in a few minutes. This is our event hall. We have right now 2 new ones as well. This is Sita Amidi. He's the CEO of Plug and Play. Plug and Play, as Thomas introduced us before as well, is the biggest accelerator worldwide right now when you talk about startups. Of course, sustainability, it's the key word for us. This is our lovely rooftop. A few of you already have been there. We will have a few events in the future. And as with these words, I would say, let's grow up together. And we will maybe start with the part of it. So right now, we're the platform of industry collaboration. What does this mean? Our vision is, as I mentioned before, from the idea 2015 to the Europe-wide Knowing Innovation Center 2030. What do we need for that? Or why are we doing it? Thomas Stehelin, our investor, is actually transparenting this for us. He's not doing this for us right now. He's not doing this for himself, not even for his children. He's doing this for the next and over next generation. So with that, we're talking about sustainability in all the fields, right? When we talk about transformation, and I think that's one of the keywords of this event here as well, we are not just talking about technology change, it's all about people. So I really would like to focus on sustainability on the way of how can we do something for the people? What do we need to do for them that they feel good, and not about how should we build that it looks nice? The question should be, how should we build that it's usable for the people who are there, and maybe a little bit nice as well, but not at the first point because of the architecture. So we are right now focusing on entrepreneurship, exchange, and empathy. That's our 3 keywords for this platform 4.0. Why it's like this, I will talk to you later. So 2010, this was our area where we started. I have to say this area has been from the Canton, Basel-Land, and this is how we want it to look 2027. The Canton didn't do anything in the last 20 years, and so they sell it to us and meant like, okay, you can have it, you can buy it, but you have to change it in the next 2 years. We're like, okay, let's start. So this will be our roadmap till 2027. These 4 buildings are actually right now under construction. Number 7 will be ready soon already. Building number 8 is the building where Straumann will come in. Building number 5, you can see here right now, will be our performance technology center. That means it will be our innovation center, okay? Why I'm talking to this, the people like Uptown Basel Infinity are already here. They already started to work. We already are working with the quantum computing, right? but we didn't build a building yet. So they're right now in the building number 1, our knowledge transfer center. And that's good, because we don't have the technologies right now. We know we have the access to quantum computing, but we don't have the machines ready to use them. So we need to go to the customers and search for cases and have them really nearby. And we have to be near as well to all the engineers who are doing, in the future, all these applications. But if we're talking about quantum computing, we will need something, and that's energy, and a lot of it. So building number 7 is the point where we have all the energy coming. It's this small building over there. It's not that small. If you have time to come to Upton Basel, we can visit it. And what's there inside are these machines. So we got water energy to Arlesheim, and from the building number 7, we are bringing them to all the other buildings. When you use a lot of energy, you will have a lot of heat as well. So we're thinking about, okay, what we want to do with all this heat? And we decided to build building number 4. It's in construction right now. This building will be the building where we will have machines in there, where we can burn from one side down the wood to go and give some energy to other apartments. But as well, we are working with Primeo that they have to take all our heat from our area and bring them first to the apartments before they start to burn down, for example, old tables or the stuff you will find in the houses who are left from the other people, right? So, with other words, we are taking the energy from all our buildings and we are putting them into building number 4, and then we go to the other sites like Rheinach, Arlesheim, but Münchenstein as well, and bring them the heat. This was, but as well with another thought, because we knew we have over 25 buildings nearby who have, in this moment, gas. And we were already 2015 against it. So we were thinking about what can we do about it. So we came together with Primeo Energy, and we decided that we will bring our energy to them so we can get the gas away, and they have another solution for it without doing anything. This was 8th of February. It was a really, really cold night. We have been there till 3 a.m. in the morning because the bridge was bought in the right position so that we can connect as well to Rheinach to bring there our heat. Of course, if we have so much energy, we have to focus as well on the CEF and PV as well as e-mobility. And we, right now, so in the future, we will have 40% of solar energy, all the solar energy we will have there will be enough for 40% of our area. We have as well our own cars. We are doing a pilot project right now where two people can go and charge with these bi-directional chargers. That means if one day we will need more energy, we can take the energy from the cars. Of course, not that much as they can't drive anymore, but if it's an emergency case, we can use them as well. And of course, if they can show us that they're charging with sun energy, we will pay them to give us the energy they're charging in their homes. But how did everything started, and how are we knowing what we actually need? We at Upton Basel decided that for the Industry 4.0, we will take 3 clusters. Cluster number 1, it's healthcare, transportation, and industry. Afterwards, Hans-Jörg Fankhauser, the architecture and the developer, started with Thomas Stehelin, the investor, to do this page. So they talked about, what does this mean for us? As we can see, they talked about IT technologies, mobility and logistics, Industry 4.0 and robotics, healthcare, smart cities and society, finance, tax, and law. I would like to remember this was maybe 2016. So it was not right now. And if we have a look on this, you can see already a few years ago, they talked about electric mobility and about, for example, biotechnology, digital society, and car sharing, and all this stuff we're talking right now in the machine learning over here, artificial intelligence. But they had a look on themselves, and they were like, you know that I don't have any idea about all of this, right? So Hans-Jörg Fankhauser, the architecture, was like, yeah, I don't know either, but I have an idea. So they got the innovation scouts, and they went to these events like you are right now, and listened to the people what they were talking about. And the trick about this was, if you go in, sit in the front, there are always spaces, right? And if the room is full 10 minutes before, the speaker may know something you would like to know. Even if you don't know what they're talking about, the speaker will know something what the people inside the room would like to know. If after 10 minutes the room is empty, go. If it's still full or still are people coming in the moment the people are applauding to them, go forward and say, hey, did you know Uptown Basel? We should meet. This is our amazing team. Our women, of course, we have some men as well. But I would like to really talk real quick about these three. We have two more inside the group right now. This is not a news picture, but these are our innovation scouts. And one of them was as well Alexandra Beckstein. Alexandra Beckstein is right now the CEO of QI Ventures. I will talk real quick a few words about it later. But we needed some more help. So we went to the fastest accelerator in the world, one of the biggest ones actually, named Plug and Play. Plug and Play has a lot of different places all over the world, and they're having a look on over 1,200 startups every year. We went to Munich, and there we saw some interesting stuff, and an interesting company named Roche. Everyone who knows Basel maybe knows the Roche Towers, right? So the pharmacy. And we always were thinking about why are they building these big buildings in Basel? I mean, why do they need so much space? And when we saw them at Plug and Play pitching other startups, we were like, okay, we understood. So they're preparing the buildings to buy other startups or to have some space for the startups that they can go in and work with them together to collaborate, right? Another really important person for us who the Innovation Scouts meet has been Dr. Heike Riel. You may think, so she's the head in science and technology at IBM. She's an amazing, powerful woman. I really, really like her. And the funny part about this is the first thing she did was she worked with, what is the name of the job when you work with wood? When you do the... With wood? Yeah. Carpenter. Carpenter. She was a carpenter first. Thank you, Thomas. She was a carpenter, her father as well. And after doing the school of a carpenter, she was like, Dad, you know, it's really fun to work with you, but I need to do something else. And now she's at IBM, and we asked her, what should we do? What do we have to do if we talk about quantum to go into the future? What do you need from us that we can help you to prepare for this one moment? And she was like, we need students. We need more people who know about this, about quantum computing, how to use them, how to rebuild these algorithms and all this stuff. So we went to the Fachhochschule Nordwestschweiz, and for the next 3 years we paid a new, what's the name of it? A new, like, thank you so much, in this field. So what was I talking about is, this is the course we are right now. This is, so we are in, this was 2021, when they told us that, yeah, they maybe need till 2026 that we can reuse, that we achieve this point of, so this is where we are today. And this will be the point where quantum computing maybe is higher technology than usual computers, okay? It doesn't, classical computing. It doesn't mean that we won't need classical computing anymore, but this will be as well the point where all the codes we have at the banks and all this time will be locked. So what we are saying is, we need to start today, that we are prepared for this moment and that we can actually take out all the knowledge we have to use it and take the opportunity to do some different kind of stuff. So this is the Quantum Basel with Uptown Basel Infinity, where they work with startups, research institutes, university partners and corporates. And their clients are, of course, the partner of the Industry 4.0, but so many others as well. They started to collaborate with Startups Acceleration Program. This is Alexandra Beckstein doing, because she has a fund of over 500 million, where she invests in quantum startups and AI startups, who work with them together, so they will pay them and they will have their own program, accelerated program, with the points they need. So they don't have like a program you go and you stay there. They have a program where they give you whatever you need. Only real quick, we have the Pioneer, this Knowledge Transfer Center of Basel, and we have a certificate called SNBS, where a lot of points are needed to be done under, when we talk about sustainability. This is the Pioneer, and these are our tenants, as Thomas mentioned before, who work together with machines. This is how it will look like in the future too. So you maybe should talk to me later. This is how it looks inside, our lovely river and our services. So we will have 2,500 workspaces in the future. We have a store where we can go with an app, buying stuff 24/7. Sustainable energy, data hub and security center, the fast accessibility to public transport, restaurants, etc., etc. I wanted actually to speak about a lot of other things as well. This is our rooftop, but the things I would have and talk to you right now are actually the things I would tell you in a tour. So please, let's connect, come to Uptown Basel, and I will show you around into the world. Thank you.
Thank you so much, Iria, for your very interesting speech. One question, the energy autarky of Uptown Basel, on which percentage is it by now? I read something about 40%, is it correct?
That's actually correct, yeah.
Have you got a goal, when you want to be absolutely 100% autark? Is it realistic?
That's a really good question, though. So the thing is, we don't know what will happen in the future, right? So we will. I know we will have a peak somewhere where we will use a lot of energy because for example, the quantum technology is not that good right now. So, for example, if we talk about ChatGPT, I mean, I think all of you know how much energy this needs, but when we have the solutions for it, it will go down as again. So I think I don't know what our goal is in this occasion, but of course we will keep up with new startups to find our solution to have the minimum possible.
Thank you very much. To get to new innovations, you mentioned, for example, you have innovation scouts.
Yeah.
Also, one of your tenants is Plug and Play. Plug and Play is the biggest host of spin-offs or startups. They host in about 40,000 worldwide. And there is also, is there a Plug and Play Ukraine existing? Do you know that?
Actually, I don't know that, but we should connect you guys to them and have a look what we can do to that you can have them there. So even we have a lot of pitches and events over there. I would like to invite you to some of them so you can meet them directly and talk to them at events. Perfect. Thank you very much for that. And one thing which would interest me is how can you bring together, you said it's all about people and not just technology. How can we combine these two groups? How can we combine humans and machines? What are here the best solutions or the best concepts? That's a really good question, though. I mean, we always will need people behind the machines. It's not about letting machines doing our work. It's about taking the machines and automate things that we can focus more on the people and on what we're really good at. So I don't think that the machine will take over the world and we don't have any more things to do. I think the machine will help us to have more time to focus more on ourselves, to focus on networking, to focus on come together, on collaborate with other people. Thank you very much. We are really proud to have you here and that you are also a lecturer for us at Uptown Basel. Thank you very much. Thank you. So now let's come to Daniel Jordi. As I already mentioned, this collective protection, the Swiss approach, we are really interested in this Swiss approach because we know that a lot of people died in Ukraine during war because they had no place, no sure place to go. So would you explain us the Swiss solution, please?
Gladly, thank you, Mr. Rohner. So welcome everybody to this presentation. I'm going to show you how we came up to this system from which I personally think is probably one of the best we have in the world. It's been efficient, rather cheap, as you will see, and it all started with the law that we set in the 1960s, in the aftermath of World War II. And we said, basically a shelter shall be provided for each resident in a shelter close to the place of residence. That's where it all began, and then we started to define all this. Maybe one of the crucial definitions they set in the law, in the requirements, is about that one. It's 100 kilonewton per square meter, which is approximately 1 bar of the effect of the blast. Why is it so crucial? Because that's a physical definition. It's not a definition due to a weapon. It tells us which physical effect should you survive, and from all this we made the dimensions of our system. So I think that is an important thing, and that's why it is still, after 60 years, accurate to build the shelters for that. About the money, so of course everything is about the money. The federation sets the frame, sets the technical data, what you have to do for your shelter. We pay the costs for protective premises. but only the additional cost. If you build a cellar, if you build a basement anyway, we pay what you have to invest additionally to have the protection. So for example, I saw there a nursing home. There is already a cellar planned to do it. So why not just reinforce one room for the inhabitants, and then the government pays the additional cost. So the costs we have for every place we had in Switzerland is 1,500 Swiss francs. It's approximately $1,500 for a protection over 80 years for every inhabitant in Switzerland. That's not much. That's coffee and a couple of coffees a day in a year. In Switzerland, it's not that broad. We said we cannot evacuate horizontally, so we have to evacuate vertically. So we built the cellars down there. It is against conventional weapons, the effects of nuclear weapons, chemical weapons, and biological weapons. The idea is you go in the cellar, in the basement, and are protected there. The other idea is we built straight and simple geometry with ductile construction. It's more important than to have an exact calculation. You will have losses in any way if you have a war, so make it ductile, make it as cheap and as good as possible with a ductile construction. And it is a protection for survival. It's not for living, it's just for survival. What do you need for survival? Respiratory air volume, 3 cubic meters per person and hour. You have 1 square meter of shelter place, so you have the beds 3 atop each other. Sanitary facilities, simple and independent. It all has to be independent. So we have shelters for the populations. That's for the population, that's the blue part, and we have protective premises for the civil protection organizations, which can be command posts that you can use in catastrophes as well. If you have a catastrophe, ground slide or a flooding, then the cantonal command structures will be set in place and they work from this cellar. So it is for several uses also in catastrophes, not just in war. So the blue part, private shelters, that's the ones you have in your own house. We're going away from them now. Up to 2010, we built in every house some shelters for 5 to 7 people. This is not very cost efficient, so we're going now to public shelters where you have bigger shelters which are easier to keep up and which are easier to man in a case of an event that you need it. We have cultural property shelters, which is very important as well. Then the protected premises, command posts for rescue units, facilities, and sanitary services. It's about 370,000 shelters in Switzerland. We have a place for every inhabitant. That's more than 9 million shelter places. 2,000 protected premises for the civil protection units. Sanitary service facilities, we have many at the moment. We're at the very moment discussing what to do with them because the health system is basically only just economically steered at the moment, so they do not have capacity to man underground shelter places. So we are at the moment discussing, before we're going to renovate them for many millions, we want to know how can we man them, what type of medicine can we work in there. So, armed conflicts, the 4 weapon effects we protect our people from. You have explosive projectiles, bombs, you have the explosion pressure, and you have debris. For this you have a sturdy concrete construction, which is reinforced by steel, of course. You have incendiary weapons, The shell of the shelter is protecting for a certain time against this because its thickness, it keeps out the heat. It's not flammable. If we talk about nuclear weapons, the main energy is from the air blast. We have some thermal radiation and we have some nuclear radiation. The air blast and the shock wave, the air blast induces actually a shock wave in the ground. That's the ground shock. We tested this in the 1990s with our shelters in US. And the whole shelter remains intact in a ground shock due to this 100 kilonewton per square meter, which means it will be displaced in the ground by 20 centimeters. But it still holds for this induced seismic shock. That's the shock induced by the air blast wave, which induces its energy into the ground. Debris we had before, thermal radiation, fire, and the primary nuclear radiation protected by the concrete, which keeps away a good part of the radiation. They are protected against the electromagnetic pulse, so the lamps in there or the electric installations are still working. That has to be tested. And the radioactive fallout, we have aerosol filters in the filtration systems in there. So, as I said, underground, reinforced, we have blast lids, so the whole thing is airtight besides the ventilation system. We have overpressure valves and we have explosive protection valves here, which have to close within 4 milliseconds when the air blast comes in, that the inhabitants are protected. And it has to open again because you need the air then to breathe. We have emergency exits depending on the height of the building. It is defined how long it has to be, how far away the exit has to be from a shelter. So, once again, it's only survival facilities, it's simple and robust, and you have what you need to survive. Very often, public in Switzerland talks about it's against nuclear weapons, it's atomic protection, shelter. That's not absolutely true. That was the outer frame we set physically. We said you can survive 2 weeks in there with the food and the water and the sanitary facility. But that was just the outer limit of the definition. So we think usually you will go down during an attack and then go up again. Chemical warfare agents, we have volatile aerosol gases, and we have settled liquids, and biological means, which usually are aerosols or droplets, when you can protect. You have there aerosol gases, warfare agents, and the shelter shall be safe, so it must be airtight. Meaning then you need to have a filtration. So we have there a filtration system. Before you have seen it was closed circuit there. You just used it for ventilation. If you have a chemical weapon attack or gases attack, any gases attack, you go through a carbon filter. That's a hugely defined, the dimensioned carbon filter with aerosol filtration as well. You have overpressure in the system then. You can work it by hand, you can work it electrically, so it's absolutely proof for any event. In the end, you can work it by hand if nothing else works. And you have the exhaust air through the overpressure value, and then when a bomb attack comes, the value closes itself, that you don't have the overpressure in there from the blast. And again, you have the exhaust gas there. So it's absolutely tight against influx of any gases. So in natural disaster, as I said before, you just bypass the filter and then you have just a ventilation system, because otherwise the shelter would be airtight and you survive. The air is calculated for surviving without ventilation about 2 hours. For this simple system, you need to have all the components matched together. For example, the screw anchors, they have to be tested. They have to fulfill certain requirements, specification, which we test in our labs of our office. The beds have to be tested against the shock, the filtration, against the chemical warfare agents. So this is all tested batch-wise, and every 5 years they have to reapply for the test, the companies that produce those systems. So I think the protection of cultural property I mentioned before. I'll let you read this sentence of the Hague Convention. I think always in the beginning of a conflict, people think, okay, we have to protect ourselves first. But in the end, you have to protect your culture as well. As you can read in the newspapers what happens now in Ukraine. You have seen this in Syria, you have seen this in any conflict over the last 2,000 years. If you want to extinct the people, you have to start with its culture. So that's why you have to protect the culture. We do this with an inventory. We have an inventory which is online available, where you see all those cultural goods we protect. We have the documentation in a protected shelter. You see there, that's in a mountain, where we have up to 80,000 microfilms. Still microfilm, not electronically, because microfilm you can firstly store for at least 800 years. We tested that with simulated aging. Plus, you need no technology to read it. A candle is enough, or sunlight is enough. So that's why you have to keep it simple and sturdy as well. We train our civil protection forces for protecting the goods. For example, the leaded windows in churches, you can take them out. There are prepared wooden boxes where you can store them and transport them in a safe place. We have also Safe Haven, which we work together with UNESCO. If you have an armed conflict, any state can make an official request to Switzerland. We have prepared state treaties, and then you can transport those goods in the so-called Safe Haven. That's an area of 600 square meters in a protected site where a state then can bring its goods. It has the status, and that's important, it has the status of duty-free zone, so the state has always the possibility to take them back and bring them, so they don't have to do any official things to export the cultural goods. You have to think of that because it's cultural goods in the end. So that was a brief overview, very brief overview of over our system. Simple, sturdy, I would say cheap shelter place for 1,500 years, francs in 80 years is not that much. Thanks very much for your...
Thank you so much, Daniel Jordi. I'm wearing a watch from Michel Jordi. Is your brother?
Has nothing to do with me.
No, to be serious. What would interest me is the alert system. How is Swiss? How do you in case of an alarm? How do you alert people?
We have sirens, which are built in the whole system as well. They are tested also against shock and all that. So if you look around, you see them on certain houses. You have the sirens with different alarms. That's one thing. We have an app, the Alert Swiss app, which gives you an alert. This we can also, that's connected with the sirens, so a canton can alarm in a catastrophe or in a war the people of its canton or of its place.
Yes.
Plus, we have, of course, the radio.
The radio.
We still have the radio. We keep onto the radio, even though it's not modern, but the radio is the only available media which is free of cost.
Yeah.
So you have to make sure that without any financial costs, you can alarm people.
Perfect. Another question is, you mentioned that we go away from private cellar to public shelters. Mm-hmm. How difficult is it, for example, for an underground car parking to make it as a bomb shelter? Is it a goal or is it another goal?
Can I have the slides again? It's not that difficult. You need to reinforce the concrete, firstly. Yeah. Secondly, you have to have a blast door like that, which is usually a huge sliding door. Yep. We do have car parks, actually, which are protected, or at least parts of them. Sorry. Then you have to have ventilation systems. Actually, the one I had on a picture there was one from a car park, I think.
Ah, okay.
Hang on. Working on it. That one. That could actually be a car park. You see there the emergency exit, and then you have whole batteries. We have even bigger ones. So if you have a huge car park, you have filters with up to 300
cubic
liters capacity of chemical warfare agents. Yeah.
Okay.
And we test them fully. We fill them completely with substance in a batch test.
Thank you very much. We open the questions. Miriam.
Well, thank you very much. My name is Miriam Sick, and I'm now also working for STC. Therefore, I'm pretty sensitive now with the protection of people concerns. We are not only talking about protecting people from bombs in shelters, but we also need to think about protecting people from people in a shelter. I mean, there are reports from other countries when people go to shelters. There are, for example, cases of sexual harassment within the shelter. What are the thoughts or what are the measures you take in order to protect vulnerable groups of people?
Mm-hmm. Now that's actually problem which has been solved before, which is not solved anymore, because we had, in the beginning, we had people from the civil protection who were responsible for all these shelters. That's the head of the shelter then. And he was in there. And we have checklists, what you have to do, but we don't have the people at the moment. So we're at the very moment discussing exactly this, how can we get the people again to care for the people in the shelters.
Thank you very much. Other questions? Yes, please.
Thank you a lot. I want to know, do you have a norm in what time people should be there directly in this bomb and shelter?
Mm-hmm.
After they heard alarm?
It's all on the internet. I would say it's 60 minutes, within 60 minutes. Yeah.
Other questions? Other questions from the audience? Also to Iria or to Pius? Who wants to question? Do you have a question?
Thank you very much. It was a very interesting presentation. I think it was very useful for our Ukrainian colleagues. And I saw here in the room there was mayors of some cities. So I hope they will approach you and take more information for the future. I have a question to Iria actually. My question is that you presented, it's very, very nice, this innovation hub, innovation center. And could you please tell like three most important things that you need? For example, I'm thinking about Ukraine. What is needed to set up this innovation center, such as a, you know, such a quality and with so much interesting thing inside and values, you know, that sustainability is a key focus. So what is needed in the context of Ukraine? So now, like three top things that need to be considered.
Thank you for the questions, first of all. So, as I mentioned at the beginning, I think we should focus on what are the people's needs. So, and not first of all on the architecture of itself. So, as we started, for example, we started first focusing on, okay, what do we actually want in these buildings? What do the people who will work there need or live there or whatever? What do they actually need? And you can't know that without talking to them. So you will have to keep in touch with all your Ukrainian families members and all the friends and all the people as you have here as well, and talk to them. What are you doing right now? What are your goals? What did you learn from the process? I mean, he's doing it a few years, right? So he maybe can tell you what was his learning in the last 20 years. And put these learnings together and take the information of the people, taking them seriously. And afterwards you can talk about, okay, let's see how this looks like. The second thing I learned from our project, for example, is prototyping. So what we do is having smaller buildings, for example, or one floor, and we start to try what we would like to escalate afterwards. For example, we had a room in the 5th floor in Mutens, nearby the school, and it is actually right now a startup center. This startup center has one center. In this center, it's actually a collaboration hub where we wanted all the people to go there and take a coffee and talk together, connect, collaborate, whatever, okay? So one thing we did is we wrote into the contracts of the tenants they can't have a coffee machine inside their rooms. Of course, everyone started to laugh, and we know that that's impossible if they go in front of floor, right? But as well, they didn't take it out of the contract. They let it there because so they could say, you know, the Funkhauser, that's a really weird man. He said we can't have it, so I'm really sorry you can't. So the CEOs are out of their responsibility and can send them there. One bad thing about it was we didn't have a community manager or a site manager over there. So we didn't have someone who physically goes there and takes them on their hand and say like, hey, I heard about that. You're doing a project, that this person is doing a project with, I don't know, we have a lot of them over there. We will hear about it later. You should meet them. And that's what I'm doing right now, and that's what we try to get better in, because we talk about collaboration, but actually not everyone knows how it works or in which fields we can collaborate.
Thank you, Iria.
Thank you very much, Iria. I have another questions. Are there other questions from our students, for example? Yes, yes.
I must, hello Michaela, my name, Czech Republic. We've been with Marcus having 8 years business in Ukraine. We were closed in in Ukraine actually, and now we are trying networking and going through the Europe, and we are for sure also trying to help and support, and we are trying to bring companies to Ukraine and invest, not to be afraid. You mentioned plug and play. I'm not IT, I'm from production, so absolutely don't understand IT. I can switch on the computer, that's all. If I have a problem, I'm calling my IT guys. You mentioned plug and play. Plug and play, they are not in Ukraine. I was checking right with our IT guys, not IT guys, but what we are as well doing. Yeah, thanks to networking, we met one crazy guy, and we are trying to help support startups in Ukraine right now, because it's not dangerous, because IT people can work from wherever, so we are trying to support IT technological startups, because Ukraine is a hub of very clever people, also ladies, 50% are not only men like in Europe, it's no normal, right? In the rest of the world, men are normally studying and working in IT. And yeah, this would be a great opportunity, because we are co-founders also of a platform called Invest in Bravery. This is a platform which is pretty new, but yeah, so we are not in IT, but we are supporting IT, because this is the first step to support Ukraine. So I use this opportunity now to ask if we would like to cooperate, because Ukraine plug and play is not there yet. Thank you.
So, of course, I'm not working at Plug and Play, I'm working with them. They're one of our best partners. I would love to introduce you to them. I have actually some few more ideas about it. Let's connect and talk about it.
Thank you very much. Really interesting. That's the place to be here, to network, and this is one of our goals. So, other questions from student side? No. So on the program, you could see that 2 persons are missing. We should have here Miss Oljena Gorobenko from the Ukrainian Wood Houses cluster. She couldn't come here, and we should have here Taras Demkura. He couldn't cross the border, so it's a pity, but. My excuses to you that they are not here. So, last questions? Nobody? So, thank you so much, Daniel Jordi, Iria Bulosa, Pius Winterlo, for being here, and it was wonderful. This brain, this spirit, this everything. Thank you so much. So we will have lunch now until 3 o'clock. After 3 o'clock, you should be here again, because this is probably one of the most important things today. These are the student projects, and all student groups, they will present their projects and itself. And yeah, I'm really looking forward for it.